To introduce our presenter for today's webinar, Asheen Sensei. Asheen joined Dassault Systèmes SolidWorks as Product Manager for SolidWorks Sustainability in 2010, based on his expertise in nature-inspired design, product lifecycle stewardship, industrial ecology, and green marketing. He has also been appointed the North American Sustainability Leader here at Dassault Systèmes and is responsible for corporate sustainability activities across all DS sites in the region. Welcome, Asheen. Thank you. It's all yours.
Thanks, Amy. I want to start off with just asking kind of the big question of why sustainability? I think we all kind of have a sense of why sustainability is important in general in our society and the environment, but why should we integrate sustainability into our company? What we find when we talk to a lot of SolidWorks customers is that there are really internal and external reasons for bringing sustainability in. So the internal drivers for sustainability, there's a few different kinds. So starting with we employees, so folks like you and me who may want to push sustainability initiatives within the company and try to get their company to go green, as they say. There's also drivers that we see from managers who want to use sustainability to benefit the bottom line. So this is primarily through cost reductions in material and energy reductions, as well as investments in greener products. And lastly, we sometimes see companies that implement sustainability strategies really from the senior executive level because they see sustainability as a long-term growth opportunity within the company and the market that they serve. And that kind of brings us to some of the external drivers for sustainability. Some of them actually come from your customers. So we've had SolidWorks users come to us and say, hey, my customer's starting to ask questions about the impacts of the products that I sell them, or what's the carbon footprint to feed into their own sustainability processes. So how do I answer that question? We also have companies who are kind of well known in the public and want to integrate sustainability into their public relations activities. And finally, some of you may be faced with complying to regulations, which are laws that dictate particular environmental impacts that you have to study and reduce for your products, or standards that are really kind of applicable throughout your industry that you really need to meet as the cost of doing business. So as Amy said, this will be an interactive session, and that brings us to our first poll question, which is, what brings you to think about sustainability at your company? Are you looking to help your company go green as an individual contributor? Are you looking to reduce your material and energy costs throughout design, manufacturing, and transport? Is sustainability part of your company's DNA in strategy or in market presence? Are you receiving requests from your customers about it? Or are there regulatory pressures from laws or industry standards?
So we'll just give everyone a couple more seconds to answer this question. So far, we're seeing a majority of people saying that reducing material and energy costs is the primary reason for sustainability at their company, followed quickly by sustainability is just part of the company strategy.
So this is something that we see a lot with SolidWorks customers. So primarily they want to look at reducing material and energy costs and then make that really a part of their overall strategy. And so it's nice that that's consistent because that's really forms the backbone of our sustainability tool, as you'll see. So let's talk about achieving sustainability as an engineering function. Seems like a pretty complex set of questions, but it really boils down to two chunks of activities. The first is environmental assessment, which is simply measuring our environmental impacts. And the second is sustainable design, which is all about using common strategies to reduce those impacts. So the first step is measuring, and the second step is reducing the impacts. And as you can imagine, it's a very iterative process. So let's start with the first block of activities, which is the environmental assessment. There are a number of tools that engineers will use to assess the impacts of their products. And this is kind of a spectrum of different tools or different classes of tools, starting from just sort of pure intuition, I'm doing this because I think it's the right thing to do, and leading all the way up to the most robust process that we have, which is life cycle assessment. So we'll talk about each of these in more detail. So let's start with engineering intuition. This is essentially saying, maybe there's a material or a type of production that I think is really not very environmentally beneficial, so I'm going to find another one. A good example is SolidWorks customer Avery Dennison, which makes office products. And as you can see here, one of the lines that they offer is a PVC-free binder line. So this is from some work that they did in essentially saying, well, we think that the world is moving away from using PVC because of its negative environmental impacts in our industry. And so we're going to start experimenting with products that don't use PVC. Really just started from that pure intuition, and they've actually built up more and more robust analyses as they've gained experience in sustainable design. So as companies build more understanding of environmental assessment, they may start formalizing that intuition into a company scorecard. This is an example of a scorecard called the Green Card, developed by a group called Zymetica. It's a product design firm. And as you can see, there's just a couple different columns for concepts 1, 2, and 3. And you can consider these concepts against your baseline product on different characteristics like use and packaging and transportation, really capturing on paper some of the intuition that you built in. As you start to understand the different stages of that product life cycle, you see packaging and transportation called out here, we really build to this idea of conceptual life cycle thinking. So this refers to the life cycle of a product. Starting on the top of this diagram with raw material extraction. So you can imagine that a product that you make, let's say with a plastic, starts as crude oil pumped out of the ground. If it's a metal, it might start with mined ores, like copper and iron ore. Then it goes to material processing, when that oil is refined to, say, plastic resins, or that iron ore is refined to steel. And then it comes to part manufacturing. And this is really, when you open a SolidWorks file, a SolidWorks part file, that's really where you're starting. And a lot of our customers are kind of just realizing that when you say, extrude a block of aluminum in SolidWorks, there's all this sort of upstream environmental impact that's associated with just getting that block to your production facility. And so that's kind of where we start having more control, we as SolidWorks designers. And then as we move to assembly, this is, as you can imagine, taking a number of different parts with different materials and assembling them together. Maybe you bolt them together, maybe you weld them together, maybe you glue them together, and each of those processes may have some impact. And then you send your final product to the end customer. That end customer uses the product over a period of time. Maybe they plug it in and draw electricity. Maybe they put some sort of fuel into it, and so we have to account for that environmental impact. And then when they're done with the product, they dispose of it. Hopefully some components are recycled. Some may be thrown in the trash, which is sent to a landfill. Some may be sent to be incinerated. The components that are recycled hopefully close the loop back into the raw material markets as recycled material. So as you can see, we really most control part manufacturing and assembly as SolidWorks designers, but there's a whole upstream set of impacts and a whole downstream set of impacts that we influence by the design choices that we make. And that's really where we start, where the basis of life cycle thinking is formed. So as we start to understand the product life cycles, from, as we call it, cradle to grave, we can start defining some numbers associated with those life cycles. So the first kind of tool that does that is what we might call a qualitative LCA, or life cycle assessment. This is a spreadsheet from 3M. So if you see across the top, you see some of those elements of the product life cycle that you may recognize, from material acquisition to final disposal. And on the left-hand side, you see some different groups or categories to measure environmental health and safety effects. And the idea here is you assign numbers into these as you do the assessment. As we start to really ask what those numbers are that we put into the cells here, We can build to using industry standards or industry scorecards, many of which are based in the LCA science. So this is an example from the Outdoor Industry Association. It's called their Eco Index. And again, across the top, you see the elements of the product life cycle. But now on the bottom, you start to see some specific environmental impacts called out, like land use, water consumption. On the far right, you see energy use and greenhouse gas impacts. In between the top and bottom is essentially the process that we get to come up with those measurements. So finally, we might actually refine this to a full life cycle assessment. Now this is an ISO certified process governed by ISO standards 14040 and 14044. And basically what it says is to do that kind of stepping through the product life cycle by starting with a goal and a scope, so asking what are the questions that I want to determine the answers to, so comparing two products or two materials, for example, and then doing an inventory analysis, which is really just understanding what materials go into each step, what wastes come out, and how much energy and what type of energy goes into each step. And then doing, finally, the impact assessment, which is using some predefined calculation methodologies to assign environmental impacts to each of those material and energy inputs and outputs. So it's really kind of doing the LCA in a very robust and scientifically tractable manner. So you may ask, well, if this is the best tool to use and the most robust tool, why don't we all do that? Well, you should consider that each of these tools has an increasing amount of cost and time associated with it. Intuition is maybe something you can do pretty instantaneously. On the other end of the spectrum, a typical LCA, a full LCA according to the ISO process, takes on average 3 months per product and about $30,000 to perform. So of course, you've got to pick the most appropriate tool for what you're trying to achieve. So that brings us to our second poll question is, we'd like to know which tools have you explored for environmental assessment and understanding the impacts of your products. And these, as we've talked about, can range from intuition or a scorecard you have in your company to just sort of thinking conceptually about the life cycle assessment to actually performing a qualitative or a fully quantitative LCA according to software or an industry standard. So I'll give you a moment to let us know, what tools you've used at your company.
So far, Shane, it seems like most are saying engineering intuition, but we have a good amount of 42% saying they've done conceptual lifecycle thinking as well.
Great. That really fits in with our approach to SolidWorks sustainability, which is trying to build the LCA thinking into the tool so that we can sharpen your intuition about impacts. So where does SolidWorks sustainability fit into the set of tools? Well, what we do is we take real LCA data and actually integrate it back up into the design phase. So we're trying to give you the robustness of LCA data, but without all of the time and cost of performing a full LCA. So to do that, we've partnered with an LCA firm called PE International, who's been doing life cycle assessments for 20 years and gathering all of this data that we now squeeze into SolidWorks so that you can do essentially a qualitative LCA. If you imagine that spreadsheet with kind of pre-filled numbers in it, that's what we try to allow you to do in the design phase. So that's how we measure impacts. But of course, measuring is not very useful without using some strategies to actually reduce impacts. So here are some common strategies that engineers use to affect that second block of activity, which is sustainable design or reducing impacts. A couple of common strategies that I'll show you in a moment include lightweighting or just removing material, maybe making a shell a little bit thinner, or even changing the material that you use and choosing a lower impact material, manufacturing something in a different place, or manufacturing it more locally to reduce transportation, or improving the energy efficiency of a product, particularly in the use phase, or finally designing it so that it can be disassembled and recycled. So that brings us to our next poll question, which is, we'd like to know what sustainable design strategies have you tried, or if you're just kind of stepping down the path of sustainable design, which ones are you considering using at your company? Are you considering lightweighting a product or redesigning the geometry, or changing a manufacturing process or place where you manufacture, reducing the energy required for the product, using a different material that's a lower impact, or designing it to be just disassembled and recycled?
We'll just give people a couple more minutes to vote here, but it looks like we've got a majority saying they're doing either lightweighting or redesigning geometry as the primary or most promising design solution, followed by actually looking at design for recyclability. That seems to be a big one, which is great.
Excellent. This is, like the other poll questions, consistent with what we see for SolidWorks users. And so I wanted to show you some examples of how that actually happens in practice in the SolidWorks sustainability tool. So let's start with the example of this, this little 5-gallon bucket. And if you're more accustomed to metric units, you can substitute a 5-liter bucket. But I'm really more familiar with what a gallon is. So take a look at this bucket. If you look at, the design requirement is essentially to hold this amount of liquid. And so what we're asking to do is to do that function as sustainably as possible. Now, one question we might ask is, how do we understand how to measure and reduce the impact? So the piece I spoke about environmental assessment, that's really in the upper part of SolidWorks sustainability here. This is where we, and this is at the assembly level, and you'll see at the part level in a moment, this is where we basically tell sustainability, here's where it's being assembled, here's where it's being used, how it's getting there, and what happens to it at the end of life. And we've got all these defaults baked in if you're not really sure what happens in your case. And then down here is the results. Here are the environmental impacts on the 4 metrics that we measure, which are carbon footprint, total energy, and air and water impacts. So one of the questions we might ask now that we've done this measurement is, how do we reduce the impact? Our assembly visualization tool is great to take a look at this, where we can actually sort the parts on carbon footprint. So you can see here very clearly that this bright red body, this plastic body, and not, for example, the metal handle, is really what's creating the impact, the majority of the impact. So there's a couple different things that we could do to reduce the impact of this, this body. First, we could take a look at the different materials that we have. So if we stick with plastics, there's a number of different plastics that we could choose, but we don't really know the different impacts of those plastics. So we've got this great tool called Find Similar Material, where we can actually say, okay, here's the engineering characteristics of the part as it's made in the ABS plastic that we've set as the default for this part. And so let's say that we want to just look for another plastic or another material with similar density. We can actually search the SolidWorks material database for any material that has that similar density. So as we click on each one, we can see the comparison of the new material with the old material down here. So in this case, ABS polycarbonate is actually worse. And you can just sort of walk down these different materials and find one that actually has a better impact, but has the right engineering characteristics that you need for a successful product. So that's one way, is changing the material. Another is looking at the manufacturing region. So we can actually try these different manufacturing regions to see which one has a lower impact. Let's say, for example, we want to manufacture this in North America as opposed to in Asia. And so what we can quickly see is the impact of the changes that we make on the environmental indicators. So you can see here we've cut the carbon footprint by 20% and cut the air and water impacts almost in half. But another way is to just redesign the very geometry that we use to respond to this design question. So this, as you can see, has a current carbon footprint of about 8.8 kilograms here. If we tried a different solution, let's say what we try is looking at this bag-in-a-box model. So this is a plastic liner that holds the same volume, covered by a cardboard box. Little spigot here that you'd use to to pour out your wine. I'm sorry, your liquid in general. And we can look at the actual carbon footprint here and see that it's 3.3 kilograms, which is less than half of the original solution. So there's a number of different things that we can do to more sustainably hold that liquid material. Let's look at another example and look at a geometry change for this example that you might be familiar with. So Poland Spring actually typically used the bottle on the left, and then they decided to redesign it to package water in a way that was more environmentally friendly. And they released what they called their eco-shape bottle on the right. And so what we decided to do was take a look at that in SolidWorks and see if we could design both designs and try to see if one was actually more environmentally friendly. So this is the original design, and we just used some calipers to figure out thicknesses and things like that. And as you can see, it's got a carbon footprint of 0.126, and we could certainly look at this on all 4 indicators as well. And if you look at the new design, the eco-shape bottle, it actually has a carbon footprint of 0.115, which is about 15 to 18% more sustainable if you look at each of the 4 indicators. So it is, in fact, a more sustainable design. So it's a great way to measure those design changes that you want to make. And lastly, let's look at the example of an electronic device, because up until this point, we've looked at making changes in material, manufacturing, and geometry. Let's look at changes in the use phase. So some of you may have different products that use electronic components. We do have some electronic components in the SolidWorks Sustainability Material Database. And I also want to show you that we do consider the energy use over the lifespan of the product. And so digging a bit more into the results, you've seen these pie charts here. What the pie charts indicate is, if you recall that circular diagram starting with material and manufacturing and assembly impacts all the way to the use and disposal, this pie chart actually breaks down the environmental impacts on those categories called life cycle stages. So the material, the manufacturing, the use, this particular model has a tiny end of life and transportation impact. And so what we can see here is that use is a pretty significant portion of it. So if you wanted to adopt an improvement in the energy efficiency as one way to reduce the impact, and let's say you dropped that energy requirement by 20% or even 40% by doing better standby modes or what have you, you can clearly see the reduction in the environmental footprint on all 4 of these indicators. So that's a great way to look at electronic devices and anything else that may use energy. So that leads me to the final couple of questions that we have for you, which is, we've shown you a little about SolidWorks sustainability, and so I just wanted to gauge, what's your general interest? Are you just, browsing and trying to learn more about sustainable design tools? Are you really beginning to look at, how you can implement those tools at your company? Are you comparing and evaluating different products for doing sustainable design? Or are you ready to purchase a product? And I'll give you a few seconds to just indicate your level of interest here, just for our records. Thanks. And our final question here for you is, we'd like to know what we can do to help you further. Would you like any further information from us, whether it's a quote or pricing from a SolidWorks representative or reseller, whether it's a demo to see some more specific designs run in sustainability that interest you, whether it's having a discussion with one of our salespeople to learn more, or none of those above options. Thanks very much. I just have some final thoughts for you. What I hope you learned a little bit about today is why companies adopt sustainability, what are some of the drivers, both internal and external. Next, how companies do that measuring of impact and various environmental assessment tools, and where SolidWorks sustainability can fit into that. And finally, some common sustainable design strategies that you can use to reduce the impacts once you've got baseline measurements. So if you'd like to learn more, I encourage you to visit solidworks.com/sustainable-design, where we have a complete sustainable design guide that is up and open for you that you can look through. And if you'd like, you can even become a certified sustainable design associate by taking an exam based on that sustainable design guide. And if you're interested in looking at some of our other products and learning more about what you can do with other SolidWorks solutions, please visit solidworks.com/upcoming webinars to find other 22-minute webinars.
Thank you, Asheen.